to our fourth speaker, Huan, that will speak about exploring the ENSO impact on catchment scale floods towards a better monthly to seasonal flood forecast. So something more, let's say, classical. Please, Huan, the floor is yours.
Hey, hello, everyone. Can you hear me?
Yeah, perfectly, Huan. Go on.
Yeah, great. Thank you. Okay, thank you very much for having me. Yes, my topic will be a little different, but still, I think is very relevant to this topic. And I'm going to talk in something a little behind of the system updates by previous speakers. And this work has been done recently by a few students and some colleagues listed here. And first, I'd like to share a few photos we took from last year's GFP meetings, as many of the GFPers and participants may not attend last year, but of course not this year. We cannot do it, but these moments hopefully can give you guys some good memories. And it's always been very nice to see GFPers every year face-to-face with a lot of updates and science chatting and meetings and hand-on experience, and also of course some beers. These are really good memories, and hope everything come back to the normal soil. And so now I come back to my normal life. Usually I talk floods. So recently, Lorenzo Avery and many others, we have a paper defines a GFP as a global network of scientists and users for operational flood risk reductions for a lot of flood events, from the early warning and to the flood recession, and monitoring all of these flood dynamics, evolutions, and their potential impacts. And recently, for this year, some of you may notice that in China we had a really serious flood problems, and we do this similar thing. And according to the something like that, this diagram defined, and we provide flood information on daily basis for the Ministry of Emergency Management of China, that's FEMA of China. And we got a lot of challenges, of course, for this response of the ongoing flood events, as already mentioned by the speakers in the last week. So one of the questions and challenges we got from this year's responding from the MEM, they potentially ask us, how can we provide this flood information even earlier? They ask for like 10 days and even longer, but we know that is very challenging. And even when we provide the monitoring wise data information, like from the real-time forecasting, and even for the one-day forecasting, there's a lot of uncertainties, as we know. And but something we have to do, and the next flood season, just I think it's just coming away. Just a couple of months away, we're going to have another flood season in China for the south part. So, what we can do for this monthly seasonal forecast is still always in our task list. So in this talk, I'm going to talk about what some prerequisite work toward for better statistical modeling or machine learning, or provide more information for the dynamic modeling for a better long-term or seasonal forecast. So every flood has their own story, and mostly are driven by different precipitation. So precipitation is a major one causing the difference in the floods. But what are the characteristics of this precipitation actually are more important for flood occurrences than others? So it's not quite yet known. So what you look at here is that we mapping the precipitation climatology based on like 16 years trend data. You can clearly see that at the top left panel, PR shows the total amount of the precipitation, and while the second one, F25, that's the frequency of the daily precipitation over than 25 millimeter. And here's the intensity of the precipitation above the threshold 25 millimeter. And the last one is the amount of the precipitation above the 25 millimeter daily. So you can clearly see that the right three panels shows the similar patterns, but the intensity shows a quite different, a huge difference than others. So the basic question we can ask right away, which one, F25 or R25, which one is more important to trigger flooding? And this kind of information is very useful for us to better understand the flood mechanisms and for the prediction. So the objective of this study is first we furnish a climatological quantification of global floods and from the model simulations, and then we quantify the likely relationships between flood and the precipitation. And in the further state, we further look into the possible impact of the climate modes, specifically here, the ENSO for both precipitation and the floods. So then the next, once we have the better understanding of this, we can use this kind of information for the better flood prediction at the various time scales. The model for this study, we use a model called the dry model, and I don't go to the more details here. And this is pretty similar as the GROFAS. We use a land surface model coupled with a routing model, and this model has been applied globally and for years and validated. Use a lot of ground observations and remote sensing and intercomparison with the other models, etc. So one interested can look into this paper, but now I'm not going to that details. I use a dry model. We developed the global flood monitoring system, the GFMS, running nearly real-timely 3-hourly 1S degree resolution globally. And meanwhile, there are also a 1 kilometer resolution global streamflow simulation at the same time step. So the system has archived more than 20 years data since 2019 to 98. And with this, basically for this study, we use the data from such system by using a better quality precipitation with the ground gauge adjusted the TMPA version to drive the model for the 20 years. And then we use every time steps data, we define the flood events. We developed the methods like the right side here. Basically, we use a threshold map using the equations like the threshold defined as the 95 percentile plus standard deviation and with the streamflow constriction, etc. And then apply this threshold map to each grid cells time series, basically putting the model simulations and compare to the threshold map, which is green, and come out to the flood events. And basically they will give you the flood indices, which are 4 here: flood frequency and the flood duration and flood intensities. We look at this for flood indices their relation to the precipitation indices, four of them are the same by you are in the previous slides. Here there are more others, but they are basically fall into three categories: frequency and intensity and the amount, but defined at different thresholds. So I'm going to share some results here. The top panels you are seeing before, and now we're connecting them to the flood. So from this, which is actually 16 years simulation results, and we aggregated by the by average at the monthly climatology, and then we can see here the flood frequency. Almost all of these flood indices basically follows the precipitation's special distributions, but flood frequency follows a beta to the precipitation amount and the frequency and the PR25 here. With those high values, basically approximately the same at the same locations in many places, but the other three indices shows a more fragmented spatial patterns, which is not surprisingly because they seem to also not only respond to the precipitation frequency and the amount, but also the response to the intensity of the precipitation. For example, the South American here, I cannot get my mouse here. But it did not show the peak on the frequency, but the flood intensity shows a more clear peak here. And when we look at the max correlated precipitation index with the flood indices for all of these four precipitation indices here, and this map shows there are even more fragmented distribution, which indicates that the nature of the inhomogeneity of our work. But however, we can see clearly collectively there are some patterns here, and we see more of the blue colors, which is the precipitation frequency, are more relevant to the flood frequency and flood duration. But for the flood intensity, you can see more the warmer colors, which is red, and it indicates the flood intensity comes into play a more important role here. If you look at this statistically, you can even see more clearly that the dominant role of the frequency of this extreme precipitation events is more important for the flood frequency and duration, but the flood intensity tends to be more associated with the total precipitation, which you can see here. There's green spikes of the green and dark blue bars here. And then we took a further step to look at these indices links at the Basin-Scale, as we usually do the flood forecasting at the Basin-Scale. So what you see here, the peak months of the flood indices shows clearly that annual preferred flood occurrence time for each individual basins. And one can look into those areas that you are interested. And we can see this flood frequency and flood duration. Again, this shows similar patterns with a similar peak time, but they are different from the flood intensity peak months, which is very important for the flood risk and the water resources management, because there's a different strategy would need to be adjusted for this kind of information. And when you compare this flood peaks to the precipitation over this flood precipitation indexes, you can see floods are usually consistent with precipitation special structures, but but we can still see some of the river basins have like 1 month ahead of the peak. That they are different, but this difference between the flood indices and the precipitation indices and the differences between those precipitation indices themselves suggest that the different effects on floods from various characters of the precipitation itself. Then importantly, we're trying to look at these indices linked to the ENSO, the simultaneous correlation between flood indices and the ENSO over those respective peak months of the flood indices. And we can clearly say that flood frequency and flood duration has significant positive and negative correlations with ENSOs. And we can even say the flood duration has even a stronger link to the ENSO in many areas. And because of time, I don't point out all of them, but you can clearly see those stronger colors, which is consistent with previous studies by Philip Ward using a different model and data. And when you look at the flood intensity, there also show different patterns with the flood frequency, but a clear pattern here is that in a north area, in the north to the 20° north, there are even stronger intensity linked to the ENSO, which is, I think this information is very important for the flood forecast. And again, we compare to the precipitation here, the ENSO links to those precipitation indices and also clearly shows that the ENSO effects actually, their effects on the floods through modulating the precipitation, which we can tell from those same signs and similar spatial structures of the relation between the precipitation and the ENSO. And we also find that just to compare this slide and to this one, flood and precipitation, you can see that we are pleased to find that actual ENSO's footprint is stronger at the flood. That can be explained that the stream flow can be a better indicator of the water cycle of a Basin-Scale, and it might also, the ENSO can modulate other important variables which affect the floods too, which warrants further studies. But these are very good news to say that the ENSO affects the floods through the precipitation. And even more important that we are looking at when we map out the ENSO's leading months with the highest correlation between the ENSO and the flood indices, so we can clearly say there are then we can say this ENSO lead months can be 1 to 5 months ahead of the floods, and with a significant relations there. And even some simultaneously the correlation peaks shows in some of the river basins, but meanwhile the significant correlation can still hold for a few ENSO lead months, which is as shown in this slide here. And this is another very good news. That means we can use more of this kind of information continuously for a few months into the future for the flood season forecast. So we don't have the time to look into one-to-one comparison, but I will encourage you, one interest can look into these figures just to play the one-to-one comparison and flip over, and you can see more interested information in your interested area too. And here's my taking home messages. I would go real quick. Flood frequency and flood duration tend to be more related to the precipitation frequency. The flood intensity tends to be associated with daily precipitation volume corresponding to this extreme precipitation events, particularly the precipitation larger than 10 millimeter. And the significant simultaneous and ENSO leading flood relations are found in many of the river basins, which is very useful. And I think that's all what I'm going to share. And for more details, I would point this go to these 3 papers and for more details. Thank you very much. That's all what I have, and I would be glad to have any questions.
Thank you so much, Juan.